Good day, madam. Today I'm going to present about inverse matrix 3 by 3, and my name is Lin Qifeng. My matrix number is 251233. First and foremost, what is the inverse matrix? The inverse matrix is a matrix such that if you multiply it with the original matrix, you get the identity matrix. Let's say if we have a matrix A, then the inverse matrix will go by the notation of power minus 1. The rules are if the original matrix is multiplied by the inverse matrix, it also equals to the inverse matrix multiplied by the original matrix, which also equals to identity matrix, which goes by the notation of I. In this case, we can call an invertible which is non-singular, and power minus 1 is an inverse of matrix A. There are also situations where we can find the inverse of matrix A. Then we will call original matrix a singular matrix where it determined is equals to 0. Alright, let us move to example 1. We are given a set of matrix A. Now what we are going to do is find the inverse matrix of matrix. We will do it together step by step. Step 2. Find the minor. We are also going to refer to given matrix A the coordinates of the elements in matrix can be stated as shown in the diagram. We are going to find the minors in matrix A one by one. For example, to find the minor in row 1, column 1, we are going to cover up the elements in row 1 and column 1, which left us with the 4 elements at the lower right corner of matrix A. Take -1 multiplied by 2, then substitute it by 2 by 2. Solve the equation and we will get the minor of row 1 on column 1. Another example, if we want to find the minor of row 1, column 2, we will cover up the elements in row 1 and column 2, which leaves with 4 elements in matrix A. Take -2 multiplied by 2, then subtract it by 2 by 2. Solve the equation and we will get the minor in row 1, column 2. Use the same concept to find the rest of minors in matrix A as shown. Answer as shown in our video. Step 2. Find the minor. We are also going to refer to given matrix A the coordinates of the elements in matrix can be stated as shown in the diagram. We are going to find the minors in matrix A one by one. For example, to find the minor in row 1, column 1, we are going to cover up the elements in row 1 and column 1, which left us with the 4 elements at the lower right corner of matrix A. Take -1 multiplied by 2, then substitute it by 2 by 2. Solve the equation and we will get the minor of row 1 on column 1. Another example, if we want to find the minor of row 1, column 2, we will cover up the elements in row 1 and column 2, which leaves with 4 elements in matrix A. Take -2 multiplied by 2, then subtract it by 2 by 2. Solve the equation and we will get the minor in row 1, column 2. Use the same concept to find the rest of minors in matrix A as shown. Answer as shown in our video. Step 3. Find the cofactor. Now, from the minor of matrix A that we found previously, the cofactor will need to multiply the negative sign to the elements at specific coordinates which are row 1, column 2, row 2, column 1, row 2, column 3, and row 3, column 1 by multiplying a negative sign at the elements of these coordinates. We will get the compact of matrix. Now that we have found the compact of matrix A. Step 4, which is to find the edge join of matrix A. The concept of the edge join is actually the transpose of character of the matrix. So that we are going to do here is we are going to take row 1 from the compact of matrix and transpose it to column 1. Row 2 becomes column 2 and row 3 becomes column 3. And with that we get ourselves the eighth join of the for matrix A. Step 5. Replace the result of the determinant and the eighth join of matrix A. We find previously into the formula of inverse of matrix A equals to 1 over determinant multiplied by the eighth join of matrix A. This will help us to create a new equation, and by solving the equation we can get a new set of matrix. The new set of matrix will be our final answer, and this is how we find the inverse matrix of a 3 by 3 matrix. Example 2. We need to find the inverse matrix for this in matrix A. Firstly, we need to find the determinant using the same method as the previous example. We can find the determinant of matrix M is 2. Next, we need to find the minor of matrix M. And root 1, column 1, the minor is 0, or meaning minus 2 equals to negative 2 in row 1, column 2. The minor is 0. Row 1, column 3, the minor is 2, and this method is applied for all other numbers on row 2 and row 3. To get the minor after we get the minor of matrix M, we convert the minor into cofactor. Then we can get the adjoint from the transpose of cofactor M. And finally, we can find the inverse matrix M by substituting the determinant and the adjoint of matrix M into the formula. Example 3. Given the set of matrix A and the inverse matrix of matrix A, we were asked to find the value of the unknown k shown in the matrix A. Now this is actually no difference in steps of solving, but we have to carry the unknown k to the very last step in order to find its value. First, find the determinant of matrix A as usual. The only difference is the answer of the determinant carries the unknown k instead of getting a real number as an answer. Next, find the minor of matrix A. Using the same method we learned previously, while having the unknown k in the set of matrix. Then, from the minor, find the computator of the matrix by multiplying negative signs to the elements at the fourth specific coordinates. After we get the coefficient transpose the coefficient matrix to get the adjoint of matrix A. Now that we have found the results, we need the last step to substitute the elements we got into formula. So right here, since inverse of matrix of A is provided, we substitute the set into the formula as well along with the determinant and the adjoint we found previously. Then simplify the equation by multiplying the 1 over determinant into the adjoint of matrix A, and we will get an equation of the given inverse of set of matrix A is equals to the set of inverse matrix A with the unknown k in it, and since both sets of matrix are equal as the inverse matrix of matrix A and the elements in the set of matrix are the same value as well. In this case, we can find the value Oh, okay. In matrix, using any elements from the equation. For example, from the equation, if we take the elements into root 2 column 1, we will get the equation of 2 over negative 2k equals to the negative 1. By solving these equations, we can find the value of k, which k is equals to 1. To check our answer, let's take one more element from the equation. As an example, if we take it from root 1 column 2, we will get the equation of 4k minus 2 over negative 2k is equals to negative 1. By solving this equation, we will also get the value of k where k is equals to 1. So if these two examples, we can see that any element from the equation can be used to find the value of k. And this is how we solve this question, where there is an unknown in the original matrix and we are required to find. Example 4. This is a matrix N with an undervalue x, giving the determinant of the N is 21. Find the value of x and the inverse matrix N equation of A. Find the value of x since it's giving in that the determinant of N is 21, so we can find the x from its determinant. Then we can get an equation in 31 equals to 3 plus 6 times x, and finally we can get the answer of x equals to 3. Question B. Find the inverse matrix of N. Firstly, we need to find the minor at row 1, column 1. The minor is 1 times 3 minus 2 times 5 equals to negative 7 at row 1, column 2. The minor is 3 times 3 minus negative 1 times 5 equals to 14. Well, at row 1 column 3, the minor is 2 times 2 minus negative 1 times 1 equals to 7. This method is applied for all other numbers on row 2 from column 1 to column 3 and row 3 from column 1 to column 3 to get the minor. After we get the minor is converted into cofactor. Then we can get the adjoint from the transpose of cofactor since we have the determinant and the adjoint of matrix N. We can find the inverse matrix by using the formula. Then we can get the answer of this question.